In this video, we're going to experiment with textures, commonly used for rendering realistic 3D images. The idea of a texture is that we can load a two-dimensional image into the CPU memory, which becomes a two-dimensional array of colors. Then we can store this texture in the GPU memory and apply this image to the surfaces of our objects when rendering them on the screen. Just as we can have multiple models, multiple shader programs, same way we can have multiple textures to choose from when drawing our 3D models. This is our presentation. Textures in OpenGL. If this is our object geometry, in OpenGL, of course, we use triangles as faces. Texture mapping applies an image like this, to the faces of our geometry and adds realism to the scene. So this is a lot easier and faster compared to drawing custom geometry and custom colors, especially when dealing with complicated objects. A texture is an array used as a lookup table for fragment colors. Our object faces are triangles, and it's a common practice to assign texture coordinates directly to each vertex. When the bitmap is loaded into CPU memory, we use a UV system of coordinates, and it's actually pretty simple. The range of coordinates is simply from 0 to 1. So the actual image can have like 4 by 4, 16 pixels like this, or it can be much larger, like 512 by 512 square with pixels and the entire image drawn there. But when we apply texture to the faces of our triangles, we always use these normalized UV coordinates ranging from 0 to 1. So then, when our geometry is modeled, we can assign texture coordinates to individual vertices. Like, for example, right here, we have a 0.4 coordinate on the U-axis and 0 on the V-axis. So this would be the mapping of this vertex using texture UV coordinates. Obviously, this is 0.75, 0.55, which is mapped over here, and then the third one is mapped to this corner of our texture, 1, 0. So this is just the initial setup and mapping of UV coordinates. And next, our geometry is loaded into the GPU. Likewise, our texture image, this two-dimensional array of colors, is also loaded into GPU, and it's actually stored as a texture object in the GPU hardware. And then when we have to draw individual fragments and assign colors to them, the color is sampled from this array of colors already loaded into the hardware. So the color is sampled directly from this texture object, and this color then is used to assign to this specific fragment. And so each interpolated fragment here gets its color from individual samples stored inside the texture object. So this process of loading the original bitmap image into memory, loading texture UV coordinates as new type of vertex attributes into the GPU, and the process of sampling the colors from the texture image already in GPU memory is the subject of our discussion in this series of videos. By the way, the textures themselves are not limited to only two-dimensional type. You can have textures that are one-dimensional, simply as an array of colors that can be sampled and applied sequentially to the fragments. Or textures can also be three-dimensional, like a stack of images in GPU memory, like this, that we can choose from. And the bitmaps themselves don't always have to be loaded from a file. A mathematical algorithm can compute the colors in CPU memory at runtime.